Hari Om children. In our last class, we discussed about a few problems related to union of sets. From exercise number 1.4, we have completed the first 5 Romans, how to find union for different functions and intersection also. Now let us continue the same exercise, that is 1.4, and we have few more problems. Let me discuss that problem number 6. Now in problem number 6, I have 4 different functions, 4 different kinds of sets. I have set A 3, 5, 7, 9, 11, set B 7, 9, 11, 13, set C 11, 13, 15, set D 15, 17. These are the 4 functions, 4 sets are given, and they are asking that I am discussing third problem, A intersection C intersection D. As we know the intersection operation, what the intersection operation gives us? Intersection operation gives us collecting the common element from all the sets. How many sets we are considering? 1, 2, 3. A, C, D. We are considering how many sets? 3 sets. From all these 3 sets, we need to collect the common elements. We need to collect what? Common elements. Now let us take here how to solve this problem. See, A. What is set A? I have 3, 5, 7, 9, 11. This is set A. Intersection. Set C. What is set C? I have 11, 13, 15. Intersection. What is set D? We have 15 and 17. Now just you observe here, is there any common element among all these 3? Is there any common element among all these 3 sets? Now 3 here I have, but I don't have in these 3 sets, so 3 is not common element. 5 I have here, but it is not in these 2 sets. 7 is not there in these 2 sets. 9 is not there in these 2 sets. Now when I talk about 11, I have 11 in first set and I have 11 in second set, but I don't have 11 in the third set. Means I am not finding any common element among all these 3 sets. There is no common element. If there is no common element, what is our answer? Our answer is empty set, which is nothing but 5. There is no common element between all these 3 sets. Means we have an empty set. This is about problem number 3. Next we have problem number 6. A intersection B union C. Problem number 6 we have A intersection B union C. A intersection B union C. Now let us how to find this problem. As we know the Bartmas rule. Bartmas rule means what? Brackets. First we have to give priority for brackets. Within brackets what we have? B union C. Means first we should find union for the sets B and C. Then we can go for intersection operation between A. I have 2 operations in this problem. One is union operation. Another one is intersection operation. Now let us perform union operation first, then we can perform intersection operation. So I am going to find B union C. B union C. What is set B? We have 7, 9, 11, 13. Union C. What is problem number C? 11, 13 and 15. What is the meaning of union? Together. Union is nothing but what? Together. Means we need to combine all these 2 sets elements. Now let us combine what we have here. What we can get here, Mona? 7, 9, 11, 13 and 15. These are the elements we can get. Now I am going to find A intersection B union C. Now A intersection B union C. A. What is set here? We have 3, 5, 7, 9, 11. 3, 5, 7, 9, 11. Intersection B union C. What is B union C? We have 7, 9, 11, 13, 15. 7, 9, 11, 13 and 15. Now we have what is the operation here? Intersection operation. Now what is the meaning of intersection? What is the meaning of intersection? Collecting the common element. Now what are the common elements we have? Here I have 7, 9, 11 and here also I have 7, 9, 11. These are the three common elements. So our answer we have 7, 9, 11. This is about problem number 6. First we should give priority for brackets. What is there within the brackets? B union C. Let us find B union C. Then we can have the intersection operation. This is about problem number 6. Next we have problem number 8. What is there problem number 8? Problem number 8 we have A intersection B union C. A intersection B union D. This is A intersection B union D. Problem number 8 is just like problem number 6. What we have done in problem number 6? First we have done B union C. Then we have done the intersection operation. Here also the same procedure we need to continue. So first we should give priority for the brackets. Means first we need to find B union D. Then we can apply the intersection operation. Now let us see here. B union D. What is B here? 7, 9, 11, 13. Union. D. What is D here? 15 and 17. What is the meaning of union? Together means combining all the elements. Now let us combine the element. What we have? 7, 9, 11, 13, 15 and 7. So within the bracket B union D is completed. Now we go for the intersection operation. A intersection. Now A intersection B union D. What is set here? We have 3, 5, 7, 9, 11. 3, 5, 7, 9, 11. Intersection B union D. What is B union D? 7, 9, 11, 13, 15, 17. 7, 9, 11, 13, 15 and 17. Now let us check the common elements. Intersection. Intersection means what? Collecting the common element. What are the common elements we have? Here I have 7, 9, 11. Here also I have 7, 9, 11. So my answer I have 7, 9, 11. This is nothing but A intersection B union D. This is about problem number 6. In problem number 6 we have few more problems that you can try by your own. You can finish it, the remaining problems. Here we have problem number 7. What is there in problem number 7? If A is equal to x such that x is a natural number, B is equal to x such that x is an even natural number, C is equal to x such that x is an odd natural number, D is equal to x such that x is a prime number. I have 4 different sets here. And all the sets are given in which form? Set builder form. Now this set builder form we should convert into list form. Once if you are able to list out all the elements, then it is very easy to calculate all these values. So everywhere they ask you to find A intersection B, A intersection C, A intersection D, B intersection C, B intersection D and C intersection D. All intersection operations only we are performing between 2 to 6. Now, just I will give the list form of the sets and one or two problems I will explain. Rest of the problem you can try by yourself. Now, solution. Given. What is given? A is equal to x such that x is a natural number. What are the natural numbers we have? 1, 2, 3, 4, 5, 6 and so on. These are the natural numbers. Next, b is equal to x such that x is an even natural number. What are the even numbers we have? 2, 4, 6, 8, 10 and so on. Now c, x such that x is an odd natural number. 1, 3, 5, 7, 9 and so on. D, prime number. What are the prime numbers we have? We have to know that 2, 3, 5, 7, 11, 13 and so on. These are the prime numbers. So to solve this problem, you have to know what are even numbers, what are odd numbers and what are prime numbers. If you don't know these numbers, then the problem is very difficult for us. Now, let us come for the first problem. What is the first problem we have? Problem number 1. A intersection B. A intersection B. Intersection. Intersection means what? Common element. Set A is nothing but what? Natural numbers. Set B is nothing but what? Even numbers. Now, between natural numbers and even numbers, what is the common we have? Even numbers only. And moreover, once if you observe here, all these even numbers are the part of natural numbers, and all these odd numbers are also part of natural numbers. All these prime numbers are also part of natural numbers. Means here A is nothing but called universal set. A is nothing but called what? Universal set. And B, C, D are nothing but what? Subsets of A. All these are nothing but subsets of this A only. You are getting even numbers 2, 4, 6, 8, 10. From where we are getting these even numbers? From the natural numbers. Means all these even numbers are nothing but part of natural numbers. All odd numbers are also part of natural numbers. All prime numbers are also part of natural numbers. Means when we discuss about A and B, now common element between these two. Common elements between these two. What we get common elements? Again we get B only. As we discussed in problem number 3 in the same chapter. When A is subset to B, when A is subset to B, A intersection B is nothing but A union B is nothing but B. That we discussed. In last class we had a concept of this. When A is a subset, B is a superset. When we talk about intersection, we have a small set as answer. When we talk about union, we have big one is our answer. In this concept, when we talk about A intersection B, 1, 2, 3, 4, 5, 6 and so on. Intersection 2, 4, 6, 8 and so on. Now, what I said intersection. Intersection means collecting the common elements. What are the common elements we have? I have 2, 2, 4, 4, 6, 6. Like that, I can get all 2, 4, 6, 8 and so on, which is nothing but the answer is B. So the common elements between natural numbers and even number means again we have even numbers only, because even numbers are nothing but subpart of natural numbers. Now similarly, when we go for the second problem, we have A intersection C. It is also just like the first problem. C, what is C? Set of all odd numbers. From where we are getting these odd numbers? From the natural numbers. All odd numbers are nothing but part of a natural numbers. So here the set A is nothing but 1, 2, 3, 4, 5, 6, 7 and so on. Intersection 1, 3, 5, 7, 9 and so on. When we collect the common elements from these, I have 1, 3, 3, 5, 5, 7, 7. So like that we are getting the common element. Now what are the common elements? 1, 3, 5, 7, 9 and so on, which is nothing but set C is our answer. So like this you can finish 3, 4, 5, 6 problems. You can try by your own, by understanding the concept. Here nothing is there, only logic you need to apply. No formula, no calculation, nothing. Only the observation and applications we need to do. Next concept which I need to discuss with you is nothing but disjoint sets. Disjoint sets and overlapping sets. Overlapping sets. So, what are the disjoint sets and what are the overlapping sets? We have seen union of sets, intersection of sets, finite set, infinite set, equal set, equivalent set, empty set, singleton set, like that. Many kinds of sets we have discussed. But disjoint sets and overlapping sets, now we are going to discuss. Now let me explain these two sets with the help of one example so that you can understand very easily. Set A is equal to 2, 4, 6, 8. Set B is equal to 1, 3, 5, 7. Now what about the intersection of these two sets? A intersection 2, 4, 6, 8, intersection 1, 3, 5, 7. When we find the common element between these two, set A all are having even numbers, set B all are having odd numbers. No, there is no common element between these two. Now what is your answer? 5. Disjoint means there is no combination, means there is no common element between these two sets. Set A is alone a different set, set B is alone a different set. For example, in class 11, set of girls and set of boys. When we have considered these two set of boys and set of girls, do you find any common student from both the sets? No. We cannot find a common student from set of girls and set of boys. So set of girls are in different sets, set of boys are different sets. We can't find any common from these two sets. Means disjoint. Disjoint. Disjoint is nothing but where there is no intersection. Where there is no intersection between two sets, they are nothing but called disjoint sets. Here I have set A and set B. If I find intersection between these two sets, I am not getting any common element, means our answer is empty set, so that I can say that A and B are disjoint sets. A and B are nothing but disjoint sets. How the Venn diagram for disjoint sets? When you have a universal set, in these I have set A and I have set B. This is about set A and this is about set B. And this is about our universal set. Now you see, do you have any combination between these two sets? Set A is alone separate, set B is alone separate. There is no common between these two sets. This is the Venn diagram for disjoint sets. This is the Venn diagram for disjoint sets. Now what about overlapping sets? Overlapping means set A, I have 1, 2, 3. Set B, I have 1, 2, 3, 4, 5. Once when we observe these two sets, what you can have 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3 sets. 1, 2, 3, 4, 5 elements are there. Once if you observe here, I can say that A is subset of B. Means all the elements of A are presenting in set B also. Means A is a part of B. A is a part of B. These kind of sets are nothing but overlapping set. Means all the elements of A are also there in set B. How the Venn diagram for this? Now, when we have the universal set, here I have set B and within that I have set A. Means set A is already there in set B, means overlapping. Set A is overlapping with set B. These are nothing but called overlapping sets, disjoint sets and overlapping sets. Now we have problem number 8. Which of the following sets are overlapping sets that they are asking? Which of the following pairs of sets are disjoint? Disjoint they are asking. Now come for problem number 8. Which of the following pairs of sets are disjoint? What they are asking? Disjoint. Now we have 3 problems under this. Let us see the first one. We have the first set with 1, 2, 3, 4 elements, and the second set x such that x is a natural number and 4 less than or equal to x less than or equal to 6. One is this roster form, another one is set builder form. Now this roster form and set builder form we should convert into same format. Means if I consider this is set A, if I consider this is set B, now I need to find A intersection B. Set A is nothing but 1, 2, 3, 4 intersection. Set B is nothing but we have 4, 5, 6 because they given condition 4 less than or equal to x less than or equal to 6. So these are the element comes under set B. Now tell me, do you have any common element between these two? Do you have any common element or not? Yes, we have a common element. What is the common element? 4. When we have common element, then the sets are nothing but called not a disjoint sets. Now these two sets are what? Not a disjoint sets. These two sets are not disjoint sets. These two sets are not disjoint sets because I have a common element. Now coming for the second one. Let us consider again this is set A and this is set B. Now when we calculate A intersection B, what I have? A, E, I, O, U intersection C, D, E, F. Now let us find any common element. Do you find any common element between these two sets? Yes. Here I have element E. Here also I have element E. My common element is E. Therefore, these two sets are also not a disjoint sets. Now coming from problem number 3. Let us consider this is set A. Let us consider this is also set B. What is given set A? X such that x is an even integers. X such that x is an odd integers. For example, when I have set A is equal to set A is nothing but what? Even integers they say. Let us consider 0, 2, 4, 6, 8 and so on. And here we have odd integers 1, 3, 5, 7, 9 and so on. Even numbers and odd numbers. As we know that even numbers and odd numbers both are two different sets. We can't find any common elements. Means when we find here A intersection B, definitely my answer is empty set. That is nothing but pi. When we got the intersection is pi, then the sets are nothing but called what? Disjoint sets. So therefore the sets are nothing but disjoint sets. So first problem we have the sets are not disjoint sets. Second case also the sets are not disjoint sets. Third case we have disjoint sets. This is about problem number 8. In this exercise 1.4 we have 9, 10, 11, 12. Now ninth problem is nothing but difference, finding the difference. And as we know that the difference of the sets, the concept is eliminated from this syllabus. And 10th problem is also again finding the difference x minus y, y minus x, that also we can eliminate. 11th problem is also difference of set, that is also no need to do. And last we have 12th problem. State whether each of the following statement is true or false. Justify your answer. Under this 12th Roman you have 4 problems, and all the 4 problems are the concept of disjoint set, like this concept only, that you can try it and you can finish it. In our next concept we can have another important concept, that is completely based on Venn diagrams and the step problems. We have now only one more exercise is left over, that is 1.6. And 1.5 also eliminated from the syllabus, because the 1.5 is completely depending on complements of set. Complement of set is always depending on the difference of sets. When we are unable to discuss the difference of set, there is no meaning to discuss about complement of set also. So that exercise 1.5 we no need to discuss. Then directly we enter into practical problems on union and intersection of two sets. These are nothing but word problems that we discuss in our next class. So maximum within 1 or 2 classes we can finish this chapter. So now you can finish these problems as homework. In 6th Roman we have some problems are left, 7th Roman 4 problems are left for you, and those 2, and 12th Roman also you need to finish it, so that successfully we can complete exercise number 1.4. Hari Om. Thank you.